Eyes wide blind.
Here is the RO system, otherwise known as the reverse osmosis water system. This is basically a pure water type of system, which is required for any mechanical components or systems that are, highly sensitive or, need to be dialed in real closely. So it makes sure that the equipment doesn't get gummed up with any sort of minerals or other likewise material. And it's primarily used for makeup water for the steam system. And that's about it on that one. And if you're looking over here, these large bore pipes, these are our domestic water feeds. Those are our mains. As you can see, there are 2 per system. So 2 mains coming in for the fire protection system and 2 mains coming in for domestic water. And again, it's kind of a recurring theme with the hospital building, but it's all about the redundancy and ensuring that the patient's lives are in good shape. The generators are dual fuel. As a sort of redundancy, that's kind of important when it comes to healthcare because people's life is at risk, obviously.
Oh, definitely.
So we have both fuel, oil, and diesel.
All right.
Yeah, so the big thing with hospitals too is having redundancy in mechanical equipment. That's why you see 2 generators.
Yeah.
You see 3 cooling towers. You have the 2 fuel tanks. So again, if you have a malfunction in one of them, you always have to back up. And then you probably want some footage of these 2. These are the cooling towers. I don't know if you've got those. If you want, it's no problem.
So how long do the generators supply power for?
They are able to operate, I believe, for 72 hours straight.
Wow, so solid 3 days worth of energy.
Yep. Okay. So these are the VFDs in the air handling unit, and essentially these ramp up and down to give the equipment the appropriate speed at which they're to move at. So for instance, on the tag here, it's SF2. That's our supply fan 2. Again, there's a lot of redundancy built into our utilities here, so we have multiple supply fans and multiple return fans. We're here in one of the air handling units on the hospital. All this copper piping that you guys see is heating hot water, chilled water, and steam pipe that comes from the central utility plant we were just in. Really what it's doing is coming in through the pipes, going into the coil sections of these air handler units where the fan is blowing over both the heating and chilled water, and that produces the hot and cold air for the hospital, as well as the steam lines that come in are producing steam for the humidifiers. Make sure that there's the right humidity in the air. The job of the chiller is to obviously provide chilled water to the building. And basically what happens is there's 3 components of these chillers: the compressor, the condenser, and the evaporator section. The evaporator section creates the chilled water, and basically through the heating and cooling process, there's condensate water that comes back to these units, and the refrigerant in these chillers sheds that energy back out to the cooling towers, and the cooling towers take that warmer water and through the evaporation process, cool it back down, send it back to the chillers, and it's, that's how it cycles. So there's 3 chillers, and really one of them is for a redundant chiller. The full load of the building can be supported with just the 2. We've made provisions to have a 4th chiller in the future should the owner find the need for that load. And that's what we typically try to do throughout the building as well, is plan for future use of the utilities. So plan for extra space. These are our boilers in the 2nd floor of the Mclaren central utility plant. These boilers are used for creating heating hot water to heat the coils in the air handling units, as well as provide steam for various uses throughout the hospital. One primary use for the steam is humidification units, and those are used in humidity sensitive areas. So what we have here is the instantaneous water heaters for the domestic water system. The owner made a really responsible decision in moving to these units, and that is really to mitigate any potential for Legionella in the system. And Legionella is found in stagnant water, so by eliminating the storage tank, they are eliminating that concern. So all the ventilation you see on this is the combustion air, and then it's a really great system, lots of redundancy, and then also you have the exhaust air that goes out through the roof. All right, so this is the pneumatic tube room, and essentially the way the system works is there's several blowers in the back that create the pressure to the system, and then up top there you see the transfer units, and essentially what happens is the users of the building put the tubes in the system using the pressure of the system over there, and then the transfer unit up top kind of switches which pipe those P-tube canisters are in. So what we have above us right now is a fan filter unit, and essentially what that does is in areas that have potentially toxic chemicals or potential for that, they help scrub the air, very similar to just an air scrubber. They'll have HEPA filters, and also if you look over here, there's the test ports for those systems. All right, so in this specific example, this is the zone valve box containing nitrous oxide, carbon dioxide, and nitrogen. In the event of an emergency or malfunction in the system, the building end user has the ability to shut these off. This is located right outside the ORs.
And I'm guessing that this tank is to kind of pressure test the system, make sure that it works the way it's supposed to.
Yep, that's correct. And then also all the medical gases on the system have a detection system in case of a leak. And that fire pump services the whole building, and it's got the 2 feeds to it, and that's about all there is to that fire pump, but that's what it looks like.
So is the system already up and operational?
It's not filled. We go through on each floor and fill it just for leaks and pressure testing, but we've only gotten through a couple floors at this point.
All right.
Coming up here in March, we are going to be filling the chilled water system, and we can really only start it once there's a load on the building. Otherwise, the equipment can't really kind of take that. It needs that heat load to be able to create the cooling. I know it sounds funny, but it's true. This is the ATS, otherwise known as the automatic transfer system, and that is for the fire pump exclusively. And that's essentially when the power drops out in the building, the ATS transfers over from the normal power to the generator power. That's the whole function of that piece of equipment.
And how long does that take to occur? Is it instantaneous?
I mean, it might drop out for a second, but not much more than that.
All right, that's impressive.
So,
all right. So, how did you guys handle procurement on this job?
Yeah, so for all of our major mechanical equipment, we had a collaborative approach with the owner and the subcontractors just to get together as a team and determine what brought the best value to the job, and just pick and choose different options that made sense financially where the need was in the building. So again, it was that kind of collaboration piece that we used on the project, and it went really well for us. We honestly did not have a whole lot of delays, if any. We did have a brief delay with the air handlers, but that was primarily due to shutdowns with COVID. So, I think everyone can kind of forgive that.
Right.
But yeah, every piece of equipment showed up in time to support the schedule and move forward.
So, what are some of the major MEP differences in an environment like this compared to what you would expect to find in a residential environment?
Sure. So, in the hospital system, there's many different components that have specialized uses in the hospital. So, for instance, the P-tube system helps convey medicine to patients. That's pretty much exclusive to a hospital, although there's other uses in other buildings. But that's one. The real-time tracking system, so that it tracks newborns and whatnot throughout the building. Then you have all the medical gases, and that's pretty unique to a hospital. The med gas system has cleanliness standards that have to be met, and it's a very stringent process, and it has to be certified. And then just kind of big picture, something that differentiates a hospital from a residential building is all the redundancy amongst the equipment. So typically you're going to have N+1, which is the required load plus one extra piece of that equipment in the event that one of the pieces fails.
All right. So what were some of the major challenges you faced while installing the MEP system?
Yeah, so on this project, we took a design-build approach with our subcontractors. So that was bringing in our fire protection, our mechanical and plumbing, and our electrical contractor. Early on in the process, being a partner, identifying constructability issues, those sort of things. And honestly, no job is going to be without its issues or troubles, but I feel like that was highly mitigated, due to that approach, that collaborative group approach.
That's a really smart process. Do you guys generally do kind of the integrated project design with your subcontractors in that way, or is this more of a unique situation?
So we do a lot of design build work, not so much IPD, but yeah, I mean, it's a great way to collaborate with those different partners and hopefully get ahead of a lot of issues where you couldn't do that otherwise, where you're bringing in people to the game late where they can't impact and can't bring their wealth of knowledge to the job.
Seems like a very progressive, like forward-thinking way to go about it.
Sure.
So going off of that, what are some advantages of civil MEP planning during the process?
Yeah, so the point where it really impacts the mechanical system in a building is when you're tying in your domestic water, tying in your storm system, getting permanent power to the building. These are all things that you do on a temporary basis as the job starts, and it's just really essential to have those coordinated because you can be ready, in the project proper, but if you don't have the utilities lined up, that can really put a damper on your schedule. For domestic water, you're flushing and filling all the systems to clean them out ahead of time. And then again, with the permanent power, there's just some equipment that you can't start up on temporary power just because it's too sensitive. So you really have to, carefully consider and plan out your coordination with the utilities to the building.
Is there a specific order which it's important to install the MEP? Like, is there a way that you install the electrical and then the plumbing, or
Sure.
which was kind of the preferred order?
Yeah, so with the building information modeling process, the BIM process, typically the way that the precedent is given is that any sort of large ductwork or large pipe is installed first, just given the lack of area to move. It's kind of a fixated thing. So basically the general rule of thumb is everything big is up high to the greatest extent possible, and then the more agile trades, call it the smaller conduit or fire protection lines, that's always considered lower in that tier.
All right. So lowering the hierarchy as far as what can be fit is kind of how it goes. You take all the big
Correct.
players first and then fit in all the small stuff afterwards.
Yeah, that's a good statement. And also, particularly in our building here, the pneumatic tube system, the P-tube system, just due to the large sweeps that they have to have on their piping, that's also given precedent because in a lot of instances there's not a whole lot of flexibility that trade has.
All right, cool. All right, our next question is, could you explain to us what a CPU is and how many air handling units you have to support that?
Yeah, so the CUP is the central utility plant, and that houses all the major mechanical equipment for the building primarily. So you have your heating hot water, your chilled water, domestic water, all your electrical gear to support the building. It's really the heart of the system, and it feeds all the building. And then we have a total of 17 air handling units on the project. They're all roof-mounted. Some of them are with a combined vestibule, but there's a total of 17 units.
All right, that's a lot of units.
It is.
So how many square feet does that take? Or you said it kind of takes over the roof?
Yeah, so they're located on the roof. I wouldn't go as far as to say they they take up the entire roof. But on the patient tower, it is very condensed up there. It's very, very tight. Other roofs, there's a lot more real estate, and it's all just really dependent on the areas and the functions that they need to serve. So, that's about it on that. One thing actually I would like to mention though is that traditionally, an air handler might serve a whole floor. In our particular building and with our prefab rack approach, we had to make the ductwork a lot smaller to fit within that because we decided it was important to zone the building vertically, and that's for, again, that redundancy piece, right? So if you have an air handler go out, it's not going to take out a whole floor, it's going to take out, call it a third of a floor.
What were some of the important on-site quality checks that you guys had to go through?
Right, so on any given project, there's a difference between code required and specification required, QC. So that's the most important thing, is differentiating between those two. On the job specifically, we had to do water testing, air testing of all our lines, obviously testing of all our electrical gear, and those sort of things, making sure that substrate is free of moisture and relative humidity, those sort of things.
Right.
And then also, when we were doing our prefabricated racks off-site, we had a testing process where we tested them before they even came out to the job site, and then they'll get tested again once they're tied in and installed.
All right. So when you were measuring the moisture, was that just in the pipes, or was that for the floors and all of the
It's for the flooring, the sheet goods, and whatnot. So basically taking a probe for relative humidity.
All right. Don't want
monitoring
floors
air,
to buckle.
yeah, and monitoring air quality continuously to make sure that the relative humidity in the air was meeting spec as well.
All right, all important stuff.
Yeah, and that can be very difficult too, especially when the building's under temporary heat. Mm-hmm. So it's just making sure you're getting the proper BTUs on your heaters and fans moving to make sure you don't have hot spots and cold spots and whatnot. So.
Right, yeah, that's incredibly important, especially in this industry where the flooring is subjected to much heavier loads on a regular basis than the normal environment, because there's all the heavy medical equipment and constant walking that goes through on this floor.
Right.
So our next question is, what were some of the safety protocols that you guys had in place while working in the MEP systems? I know that working with your hands over your heads for a long period of time is one of the most dangerous parts of the job. How did you guys handle all of that? Sure.
So really, we don't treat it any different than any other job. Obviously, safety is of utmost importance. One thing that we did do on this job, though, to even mitigate that further, is go to prefabrication on a lot of these components. And what that allowed us to do is have the workers working at chest height versus being up on lifts and ladders. So they were able to do that. And then that in turn eliminated a lot of trash, lifts, and ladders on the job, and less men because the work's off-site. So inherently, that creates a lesser environment for incidents to happen.
That's cool. And then this one's just kind of an extra question, because obviously hospitals are very unique. What has been like the most rewarding part of the hospital to work on that's kind of a little daunting maybe, but when you actually see it come together, it's been really impressive?
So, and this is speaking personally for me, so I led up the prefabrication program. That's nothing that I'd ever done before, and quite frankly, was a little bit newer to our company. So to put that process in place and to develop that program and create documents and resources, for our company, I thought that was very unique and rewarding.
That's really cool.